would like to introduce David Tuber, who will be presenting AIM, Aggregated Internet Measurement. David is a product manager at CloudFlare and is coming to us today from Seattle. This is David's first time presenting at NANOG, and it's a pleasure to have him speaking with us today. Welcome, David. And Yi Olson, thank you. I'm sorry, I have working from a script.
I'll introduce myself.
Yep. Okay, that's good. Thank you. Welcome aboard.
Thank you.
Thank you. Thank you. Hello. As they said, I'm David Tuber. I go by Tubes. I'm a product manager over at CloudFlare.
And hi, I'm Yi Olson. I'm a data scientist at Measurement Lab.
And today, we're going to be talking to you about AIM, Aggregated Internet Measurement. We'll talk about a little bit what that is. Before we do, I want to talk a little bit about who we are and what we're doing here. So, as mentioned, I'm a product manager at CloudFlare. And at CloudFlare, our mission is to, if you haven't heard of us, our mission is to help build a better internet. We do that by offering a suite of products that is accessible to a broad range of user stories. So whether you're a free user who's just trying to host some content online, you can do that with our free CDN and WAF services. Whether you're an internet user in a state of concern where the government is trying to restrict internet access, we provide internet access with our Warp product. Whether you're a developer who's trying to build services, we offer services like that, or enterprise users who offer enterprise connectivity. We do a whole bunch of stuff. We've got a really big network, 285 cities, almost 200 terabits of capacity, and so many different use cases. We're really, really committed to ensuring that end users have a good experience on the internet, not just in terms of providing it, but also in showing users their own internet quality. Lai, you want to take it for you?
I would, yeah. So Measurement Lab was founded in 2009 by Vint Cerf and a group of interdisciplinary researchers who wanted to solve basically three different problems. One was the difficulty of measuring at scale in the real internet. So, not just in sort of a test bed or a small scale experiment, but something that could be scaled globally with real world traffic. Additionally, at the time, it was quite difficult to share large data sets. So that is also something that the project took on. And then the last challenge, which I think Michael Bailey spoke well to yesterday, that we still experience, is the challenge of connecting people who have expertise in technology and how to improve the internet, network operators, academic researchers, et cetera, and funneling their knowledge into policy conversations with people who have the power, money, and influence to make decisions and invest in ways that can improve the internet for all. So that last problem and that last challenge is something that we still strive towards to find solutions for to this day. So we publish open internet performance data for use by all of those parties such that we can all be looking at the same data set and looking at the same numbers. And, we might still have conversations and debates around the data from there, but at least then we're looking at the same numbers from an open source, from an open database. And so all of this is rooted in the idea that public policy decisions should be made with open source methodologies. We should all be able to understand how we got that number and why it is that it came to be the way that it is, and have an open, transparent conversation around why that calculation, why that protocol, why that measurement. And so all of this on the image here of an example of how doing this, our data is used to help map the state of availability in Washington. People integrate our tests, our open source tests, into surveys such that they can get a better sense of what's happening on the ground. So that's the kind of work we do. Next slide. Since 2009, we have collected 4 billion rows of data. A lot of it comes from these open source integrations of our tests, including the one in Google Search. The one in Google Search is actually NDT, which stands for Network Diagnostic Tool. It's our most popular measurement service, and it's referred to commonly as our speed test. And all of our tests, including NDT, but not limited to, run to servers in the interconnection point. So meaning that when a user runs one of our tests, it goes through the access network, through the transit ISP, and into the data center where ISPs peer with one another. And all of this is just to give a background, but today and just presently at Measurement Lab, we're really interested in expanding the notion of speed and expanding the notion of internet performance sort of beyond those basic throughput metrics, beyond the basic notion of bandwidth, so that we can have a more nuanced conversation about the metrics that actually affect end user performance.
It's great. So we're both here. We both do things. So let's talk about our talk. But before we get into what AIM is, we have to answer a very important question, which is, how do end users define good internet? More importantly, what do end users say when they have a bad internet experience? And we talk a lot about end users in aggregate. There are people in houses or maybe in offices. They're on Wi-Fi, but I'm going to crystallize that. I got permission from my good friend, Andrea. She's helped out a lot in this talk, and I'm going to introduce her. Andrea lives in Seattle. She is a therapist. She works in an office. We're going to talk a little bit about that office in a second. She is a photographer. And most importantly, she has no operational experience on the internet. So she uses the internet. She uses it all the time. But she has no idea how it works, which is perfect for the purposes of our talk. So when Andrea complains about the internet, we talk all the time, and Andrea says, my internet sucks, my this, my that. She doesn't say, I have, low throughput, I have high packet loss, I have high jitter. What she actually says is, my Netflix doesn't work. Or, as you'll see, I can't conduct clinicals with my patients because my Zoom doesn't work. Or my video game is laggy and I'm having a bad time in my online play. And all of this is to say that there is a disconnect between how we measure the internet with throughput and packet loss and jitter and how our users actually use it. How Andrea is using the internet. She doesn't care about packet loss. She just wants her stuff to work. And this disconnect leads to a lot of problems, especially when end users talk about internet applications. And a really great example of this was in March of 2020. We all went home and we all got online and we all fired up our web chats and started working remotely. And maybe our web chats, maybe our web conferencing software didn't work as well as they thought they would. Who here had problems when they went home and fired up their web conferencing when the pandemic started? See a couple people raising their hands. So what'd you do? Christoph Pasch actually asked this question. The answer is you probably upgraded your internet. And maybe it worked, maybe it didn't. But that's because for a really long time, the only metric that end users have to understand whether their internet is good or not is upload and download bandwidth speeds. And that's helpful for some scenarios. And in some cases, like video streaming, it's actually a very core component of those scenarios. But it's not everything. And telling end users like Andrea to understand that upload and download bandwidth is just one component, and there's all this other stuff that's very confusing that you have to combine into some metric that makes sense, is really just, we're basically asking Andrea to become a network operations engineer, which is cool. I mean, we definitely need more of those, but it makes debugging these issues for Andrea tough, and it makes debugging issues for ISP support really hard, and leads to a lot of frustration. Because if there's one place that's the happiest place in the world, it's the support queue for an ISP. So fundamentally, and Lai mentioned this, speed test should answer a really fundamental question, which is, what is my internet actually good for? Not how many megabits I can download, but what can I actually do with it? And that is the goal of AIM, which stands for Aggregated Internet Measurement. The first goal is that end users should not have to translate between operational connection metrics and end user experience. We should just tell them, this is what your internet is good for, and collect all the data we need under the hood and give it to people. And how we determine what your internet is good for should be determined in part by network operators, because we've been doing this for years, but also by application owners. If someone's using a voice chat application, the voice chat application probably has some feedback as to what actually matters for their application to run properly. So we should take that into consideration when we determine that scenario-based score. And when we do that, if someone runs a speed test and says, well, maybe my internet's not so good for voice chat, well then they won't have to just say it's because Cloudflare or MLab or any ISP says that it's bad. The application said so. It comes from the source. And all of this data gets back to network operators and researchers and policymakers who can all, as Lai mentioned before, speak and operate from the same data set that's publicly available and available to everybody so that we can all help build a better internet for everyone. Which is a really cool idea. And it's such a happy, rosy little scenario. But let's break it down and actually talk about Andrea's case in an example that makes sense. How can AIM, or how can this idea help her and help network operators live a better life? Well, Andrea works in an office. Let's talk about that office. I mentioned that office before. So Andrea works on an office floor, and she's got 4 offices. So I am standing where Andrea's office is, and Lai is standing where the Wi-Fi access point is. And I'm in an office, and Lai is in an office, and there's 2 solid walls of plaster between me and the access point. So Andrea is having problems. I'm having problems. I can't talk to my clients without my Zoom crashing every 5 seconds. I can't upload my testimonials. I can't upload my notes. But I can watch YouTube videos. I can stream the stuff that I need to stream downwards, but I can't necessarily look at it. I can't necessarily, have those conversations in real time. So what do? Well, I call my ISP and I say, I'm going to run a speed test. When I run a speed test, the first thing I'm going to see is I'm going to see my bandwidth down and I'm going to see my bandwidth up. And so Andrea, when she ran her speed test, she saw 25 megs down and she saw 7 megs up. And Lai in her office saw 21 megs down, 7 up. So what does the bandwidth actually show here? It doesn't really show that much at all. But what is actually the problem? Well, you, me, and everybody else here knows that there's 2 walls of solid plaster between Andrea and her access point. She needs to get closer to her router. And that was actually the problem. When she looked at speed tests that showed packet loss, there was 7% packet loss in Andrea's office, but there was 0% packet loss near the access point where Lai is. That data was not present in the initial speed test characteristics. But the meta point is Andrea doesn't know any of this anyways. Even if Andrea saw that she had 7% packet loss, what is she actually going to do about it? But with AIM, instead of saying you have 7% packet loss, we can say your internet's fine for streaming. You can watch YouTube videos all day. Your internet, not so great for video calls. Maybe try and fix that. And your internet's not super great for gaming. And then the other thing, and the final thing we can do to help ISPs and help network operators get better is give Andrea the tools that she needs to fix this without even having to pick up the phone. If we can tell Andrea, hey, your internet looks like it could be bad for video calls and gaming. If you're on a Wi-Fi access point, get closer to your router. If you have the ability to plug in directly, plug in. And doing all of this stuff is going to make it easier for Andrea to fix problems herself. And a 2 weeks debugging scenario where you have to call your ISP, they have to tell you to run a speed test, you have to do all this stuff. Maybe they send out a technician, maybe they don't. Takes 5 minutes, run a couple speed tests, get what you need, and fix the problems yourself. And it's not just about improving support and improving user experience. As Lai mentioned, because we can use this, because we're putting this data in open source and we're giving this data to everyone, we can use this data to make more specific claims about networks and users in a region in aggregate. We can see this data in real time. We can see this data in aggregate over time. So we can make claims like some users in this particular area are having a good streaming experience. Users on this network in this area may be having a worse than good streaming experience. You can use this data, users can use this data to compare ISPs in a region. Let's say I just moved here. What internet do I buy? Assuming that I have the ability to pick, what internet do I buy? That's stuff that not only end users, but network operators and especially policymakers really, really want to know, because it can help us make better decisions about not just where to put internet, but in the case of the United States or other places where we allocate federal funds for broadband expansion, where that money should go and who that money should help, and help build a better internet for the people who can't necessarily advocate for themselves. And that's one of the other goals of AIM. Which sounds great. We've painted a pretty rosy picture. But how do you get this data? And Lai is going to tell you how.
Good, great. I'm going to tell you how. Okay. So it's actually quite easy. So if you go to this link, which is linked in this slide, The top link is going to take you to just very quick documentation about how to get access to BigQuery. Preview there is that it's just signing up for our mailing list. So you sign up for the discuss@measurementlab.net mailing list, and you'll get access to all the data in BigQuery for free and open access. The NDT data has been available for years. It's currently available now, so you can get access to that today. Soon, the Cloudflare speed test and AIM data will be available as well. So I've put a sample query there. This could get you started at looking, at the test between this state and this state in a given city, such as New York, and linked there as well. Right now, when you go there, you will get an example query and information about how to access the NDT data, which is, again, our speed test data. Soon, it will also include the Cloudflare and AIM data. So again, this slide could be summarized as sign up for our mailing list and you will get access to the data. Our interest here is understanding what would be best for you all to access it beyond that. So I'm curious what tools you all use to visualize data. Can I actually do a straw poll? So Grafana, do people use Grafana? Raise of hands. Okay, I'm seeing a lot. Tableau. Okay, not an ad for Tableau in here. Power BI. Anyone? Okay, I'm getting over. And any shout outs for any other tools? Super helpful. People like Grafana. Great. Okay. So for example, I made this in Google's Looker, which integrates nicely with BigQuery, but it's super helpful to know that Grafana is the tool. So we'll be working on creating tutorials and an API for use there. But then the other aspect is that Cloudflare is also planning to integrate this data into Cloudflare Radar, which already includes a lot of their internal data as well. So you can look forward to that too. As I mentioned, we think a big part of this is basing all of this on open source methodology, such that when we do go to make public policy decisions, it's based on something that we all understand how it was made. So NDT7 is currently open source. You can look at our server code, our client code, it's all there, and as well as the description of the methodology. And the Cloudflare and AIMScore methodologies are also coming soon to be open sourced. Today, though, you could do it right now. You could test the NANOG network as well as the Atlanta ISPs. You can go to speed.cloudflare.com, .com, and look at your network quality score alongside the speed test metrics that we're all very familiar with. You can also get this network quality score, the AIMScore, to better understand what the internet here is good for.
Spoiler alert, it's not that great for that much.
And I did just want to, again, underscore too the analysis slide here, just in terms of public policy decision making. I think some of this is also just encouraging us to ask better questions or get our policymakers asking better questions. Currently, the conversation is extremely bandwidth centric, which makes sense in some ways, given that that is how the packages are sold in some ways. But if we can encourage people to ask better questions, not just is it meeting them the specific level of bandwidth, but also are people actually able to do what they do need to do when they go home and work from home or in the office? Can they actually accomplish the goals that they need to? Can they actually participate in society the way that an internet connection can enable but doesn't always enable? So some of this is also we hope that the data will be useful to you, but we also hope that you'll help us make it useful to others such that they can help improve it in a way that will have a lasting impact. What comes next? So these next two, so like I mentioned, it's really helpful to know that you all are Grafana fans. So we'll be working on creating tutorials and dashboards just to make it as easy as possible to use the data. The collab is a start. The quick start is a start, but we want to go beyond that. So we'll be working on things to make it easier to use the data. And we're also interested when AIMScore data is put into BigQuery, it will be based off of Cloudflare speed test data derived from it. We also want to do the same, have it be derived from NDT data as well. So then we can start to ask more nuanced questions, such as what does NDT say my internet is good for? What does that mean? Or how does that compare to what Cloudflare says? Because our speed tests are fundamentally different methodologies. What can we take from using this AIMScore on those different speed tests? And the next two tubes.
Yeah. Also what we're doing is we're trying to align our schema. So as Lai said, some of the ways that we measure stuff are fundamentally different, but also what we measure is different. We measure packet loss. We measure loaded latency. NDT doesn't yet. That doesn't mean that NDT can't. We want it to. So we want to start aligning what we're measuring and making sure that we're at least measuring the same things. And even if NDT measures upload and download bandwidth differently from Cloudflare, that doesn't necessarily mean that there's anything fundamentally wrong with either one, but we want to get at least to the schema for speed tests more or less aligned so that we can better start measuring the same stuff. That allows us to also find out some key things like explanations of differences between them, and also we can measure things like cubic versus Reno versus BBR. Different speed tests use different algorithms. And that allows us to kind of see a variety of different network behaviors over the same links. And finally, the last thing we want to do is start getting application owners to start contributing to their scenario-specific scores in AIM. So if you're an application owner and you run stuff on the internet like the rest of us and you're interested in contributing, let us know. Our contacts are, well, right there. Not only would we love to know all of the ways that you want to access the data, want to know what other data sets you use, but hey, if you want to contribute, if you have a speed test yourself and you want to contribute this data, to contribute data to us, if you're an application owner and you want to contribute to AIMScore and to your specific score, if you're an ISP and you want us to do a walkthrough of your data with you, we're open to everything. Please reach out to us. We are more than happy to get with you and sit with you and figure out how you can use this data and how we can improve this data to make it better. That's it. That's our talk. Thank you so much, and I guess we'll take some questions. We got one right there.
Hi. Sorry. Hi, Jared Mach, Washington Fiber Properties. I have a small residential ISP, and when you mentioned that the location they had plaster walls, that was actually one of the first questions that we generally ask when we're doing an installation, is how many actually have plaster walls, because a lot of them have wire mesh in them, unless you're actually talking about drywall, which is different. But like these construction details are actually really important when doing a customer install and stuff, because a lot of older homes, if they have a plaster wall, they've got a wire mesh in them, and you basically are living inside of a Faraday cage and you have no RF propagation from room to room. And so then as a follow-up on that, are you going to be actually launching a non-web based client? I know all of the cool kids these days only know JavaScript and Angular and whatever else to actually do things. But in order to get information like the RSSI out of the, the client side, which is important feedback for a lot of us to get, if we're running a service provider out of that client device, are you actually going to be collecting that, or are you just sticking with like the same boring web stuff that everyone thinks belongs in email with like all that HTML crap and stuff that isn't representative of like what the internet like network is these days? Are you actually have an app that you're going to launch that's going to measure that?
So a couple things. One of the things that we're really focused on is ensuring that we're measuring from what users are actually measuring. So if a user is using non-HTTP applications, then yeah, we want to measure that. If there are things that are not surfaced in web browsers or things that we want to get up there, we want to go talk to browsers and see what we can surface. So a good example of that would be ECN bits and DSCP tagging, right? Like we'd love to be able to surface that in a web-based speed test. It would be really cool to work with browsers and to get that stuff surfaced and see what we can surface to get stuff out there.
But like in my iPhone, you're not going to get access to anything more than NSURL connect, right? So in doing a lot of this coding. So in order to get into that hardware level detail, which is the important feedback, because I've got the customer in-home management solutions, they actually have stuff that they'll be able to tell you how strong the signal is for the individual device, which is a very important performance metric. And it feels like there's a lot of these things that the vendors have actually implemented for the client CPE side. And if you're not looking at that data or not taking advantage of that data, and you're just measuring like how fast Cloudflare server is or the nearest CDN node for whoever's hosting these points, you're not actually measuring the network. You're measuring a web application, those are two very different things. And I understand a lot of like the end users don't understand the differentiation between it. But if I'm using a Fire Stick, I can't run this.
Sure.
So I have an additional answer just from the MLab perspective. So this is also why I think open source methodologies are important. So you can integrate our test into hardware devices. So we have a Go client as well. So what you would go to from the Google search integration is the JavaScript, but you can also integrate one on the router or something attached to the router using our Go client. And so for me, what's always been interesting is thinking of not, is it this, doing it this way or this way, but doing both. So you can imagine collecting not only from the browser, but also the router and comparing those and maybe seeing if there's a difference, which would suggest that it's a Wi-Fi problem, right? And or you can think about hosting the server on the router device itself and still running from the browser and running tests from the client device to the router itself. So essentially just segmenting the paths so you can, sort of get characteristics from all these different angles. And I think that's part of, at least my theory here, is that, again, it's not about choosing either or. It's not about saying it's this, we only can get measurements from the router, we can only get them from the browser, but what does it look like to get both and compare?
Yeah, because if you look at the, I just want to, sorry, there's people, I'll finish with this, is that when you go to like a Netgear router or you look at the Arrow, the Arrow mesh or a lot of those types of things, they actually independently run a speed test and get that data.
Right.
And that's representative of actually the internet service being delivered. If you're only measuring the client side behavior on a device where you have no idea of what that next hop network looks like because you're completely agnostic because of the measurement platform, your measurement, as far as I know, it could look like I'm on the moon just because you don't actually have a way to go and understand what you're actually measuring. So I'm very concerned that you're going in publishing data or might be publishing data here that's not representative of the full end-to-end ecosystem if you're not taking advantage of the fact that the majority of people interact with the internet these days, like in their homes through a tablet or other mobile device, and that whatever measurements here you're purporting are accurate are going to be they're not going to represent the actual end user experience. So I'm concerned about that with the lack of that integration, because when the customer runs the speed test from the thing, they see your internet is super fast, and they don't know that it's one of the streaming services having an issue at that moment.
Yeah.
So
the short answer is nothing's off the table. We definitely want to get as much data as we possibly can.
Hello, Kemal Shainta from Thousand Eyes. I applaud the effort to actually make speed tests more human readable. They are useful for us, but not for a wide range of people that are using them or they don't know how to read the data. Your talk actually prompted me in the direction of thinking about the first effort towards something like this when it comes to application actually telling you that you have the performance-related issues, part of which I think that Netflix years back actually, if you were buffering or something like that, you were posting the message that you should really speak to your provider, which was a part of the larger debate about net neutrality and Comcast actually, trying to squeeze money from them because it's an eyeball network, so why not? We can do it, right? And then the other thing is, like, how do you solve this from the technological perspective? And this is more on a joke side. But, now 13 years ago, Google wrote an RFC 5841, which is a TCP option to denote bucket mood. So if you were to push for that, we would see smiley faces, angry faces, and stuff like that in our TCP packets, which could help answer some of these questions that you are posing. Thank you.
Yes, we should do that.
Emoticons and TCP? Wow. The industry has so changed. Hi, my name is John Brown, and at this moment in time, I'm affiliated with nobody other than a recovering ISP owner. Yes, I sold my ISP. Yay. But having had 17 years of experience of running both a fiber-based ISP and a fixed wireless-based ISP, understanding my customer's pain is always something that has been important to our service delivery. My concerns are, yes, we have, as Jared so pointedly pointed out, we have the Faraday cage known as chicken wire in the wall. Gypsum rock does a really good job of that as well. We also find that a lot of houses today have gone out and bought these really wonderful things called Ethernet extenders that go across the power line. which suck. Sorry. And people like to deploy multiple access points across their house. So when you're testing, how do you know which AP you're touching? And is that, in fact, the most relevant AP to give the customer's best service? It may or may not be. And there may be some ways to be able to extract some of that other than just simply pushing TCP or UDP traffic if you're getting a little bit more involved with the device and what actual AP, MAC address of that AP, et cetera, that it's associated with. The other piece that I would say is that really understanding certainly the immediate ISP's the path from the subscriber to their transit and or peering point, hop by hop by hop, can also really tell you a lot, because you could find that there's a middle mile wireless transmission facility that is part of their network that is congested, and that could be causing issues. And you could also be having packet loss on that middle mile, but everything on the end is looking fine, and things end to end seem to be good, but there's still a problem there that's causing degraded TCP performance or degraded UDP performance. So maybe being able to do hop by hop by hop analysis could also be something that would be useful. So those are my comments, not so many questions, but comments. And the more, I'll leave this with you guys on a positive note, the more we could have an open source, non-vendor specific or a vendor agnostic way that ISPs can get metrics on the quality of service and quality of experience, where you don't have to drink somebody's specific Kool-Aid. The more of that that's out there, I would support a lot.
Awesome.
Thank you. Thank you for your time and for getting up and painting targets on you, because I know some of us love to shoot arrows at targets.
Thank you.
The highlight was...
I had thoughts on one of those at least. I wanted to also mention that for every NDT test that we collect, or for any test that we collect on the Measurement Lab platform, we also collect PCAP data. So there has been ideas that we could use it to do something similar to what you're describing, at least, identify where the bottleneck was along the path. And I also didn't mention that, and this is not necessarily answering your comment or referencing it, but we also run a trace route back from the client back to the server, which can be valuable, obviously, for routing information.
Can you run a trace route the other way too?
No,
Because both ways
not
is
currently.
useful?
Yeah,
Not
yeah.
yet.
We also do have a reverse trace route tool that's not in BigQuery yet, but might be something towards that.
All right.
Yeah.
Go ahead.
So, Jacques Latour, I'm with Syrah. So in Canada, we have performance.syrah.ca, and it's all based on the MLab NDT. So we do tons of testing. We measure how ISPs do, and then they can use that to get the funding from government. So we're very in tune with this. The challenge, a little bit is NDT is WebSocket, and today's network are like, the biggest issue we have is consumers with 1 gig connection. And NDT can't measure fast enough. It only does 1 TCP stream. And you measure the performance or the quality of a single TCP stream versus speed test that can do up to 15. So one measures the absolute capacity, the other one measures the quality. So it's both are at one in each extreme. So is there plans to redo NDT so that it can measure the quality and the absolute capacity? Because a lot of people say, I bought a gig, speed test says I do a gig. When I run NDT or MLab, you get 300-400 meg with packet loss and stuff. So
Yeah. Yeah. Good question. A couple different answers. I mean, one, I'll just point out that implicit in the question is the notion that people subscribing to over 1G are the priority. I completely understand why in this room that would be the case, but often we are concerned with folks who are receiving 50 or less, right? So that's often, I will say, the policy conversations center around people who aren't even subscribing to those higher tiers and have problems of affordability and availability. So just mentioning that. But in terms of being able to measure above 1G, that is something that we've been exploring more. We are releasing a tool called Measurement Swiss Army Knife, or MSAC for short, that will enable the user to configure whether or not it's BBR or cubic, and then multi-stream or single stream, and choose how many streams. We're doing this so that we can research if that actually does measure those higher speeds better. We don't know. That's why we're creating the tool. But it is something that we've considered.
And then reverse trace route plans. So
it is currently hosted on the platform, but the data is not parsed into BigQuery. So if that's something you're interested in knowing more about, we can talk. And I think our team's already in touch. Yeah.
Thank you.
Yeah, thank you.
Your last question.
Doug Canine, Coordinated Care Services. I was, first of all, somebody who's worked in doing work with governments to try and roll out like broadband and figure out where the gaps are and stuff like that. I applaud the work that you're doing. How do like entities like governments and other firms like that gain access to, like, I would call it like usable data from you? Is it really just the links that you've got there? We can pull it all down and get it all there.
Yeah.
Okay. And I'd love to touch base with you afterwards to maybe follow up on that a little bit.
Yeah.
Thank you.
Yeah, and sorry, I know we're being tugged off, but just to tie back that last point to network quality score too. I mean, I think this is the goal, is to bring in these types of different nuances of measurements, cubic versus BBR, single stream versus multi-stream, understanding those in the context of what does it mean for your video? What does it mean for your gaming? And, I understand these nuances make sense to us, are exciting for us to talk about, but what does it mean to the end user, and how can that help inform public policy decisions? Thank you.
Thank you.